Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about product of two vectors. As we have studied addition of two vectors, subtraction of two vectors, and now we are going to learn about multiplication of two vectors or product of two vectors. So in that we are going to study about the first type of multiplication of a vector, and that is scalar product, or we are also going to call it as dot product. So let us learn about product of two vectors. See here, in multiplication of two vectors there are three types. In three types we can multiply two vectors, multiplication of two vectors. In that there are three types. In three types we are going to multiply two vectors. The first one is scalar is multiplied with vector, and the second type is vector is multiplied with vector, and the third type is again vector is multiplied with vector. Don't get confused with the second and the third type. Both are same here, but the result is, observe here the second type, when vector is multiplied with another vector, we will get the result scalar. If the result we got scalar, then this is second type. And in the third type, vector is multiplied by vector, but here the result is also vector. Is it clear? In three ways we are going to multiply two vectors. First one is scalar is multiplied with vector. Second one, vector is multiplied with vector but its result is scalar. And the third one is vector multiplied with vector but the result is also vector. So these are the three types in the multiplication of two vectors. Just I will give you example for scalar multiplied with vector. Observe here, I am going to take one example for the first type. I am going to consider vector A and its value is given 2i cap minus j cap plus k cap. Is it clear? This is a vector quantity. Vector A equal to 2i cap minus j cap plus k cap. Here this is a vector quantity. I am going to multiply it with a scalar. I want the value of 3 into a vector. What is the value of 3a? So 3 is what? Scalar quantity. It is a number. It is not having any direction. It is having only magnitude. And vector A is what? Vector. So scalar is multiplied with vector. How to multiply? It is very easy. Observe here, vector A equal to 3 into, here what is the vector A value here? 2i cap minus j cap plus k cap. Simply we can multiply scalar quantity with vector quantity. 3 2s are 6 I cap minus 3 j cap plus 3 k cap. So this is what? The first type, simply scalar is multiplied with vector. Right, then come to the second type. Vector is multiplied with vector but the answer we got scalar. So for example, if I am going to consider for the second type, vector A is equal to 2i cap minus j cap plus k cap. Vector B is equal to, let us take 3i cap plus 4j cap plus 2k cap. Vector A, vector B, I am going to multiply. Vector A into vector B is equal to, whatever the answer we will get, this is a scalar. I am going to write it as, for example, we got the answer C. Vector A, this is a vector. It is multiplied with vector B, this is also vector. Vector multiplied with vector, but the result we got is a scalar. Means we will get some numbers like 3 or 4 or 6 or 7. So these are what? Scalar quantities. So that means when two vectors are multiplied, if we got the answer scalar or in terms of numbers, so we are going to call it as scalar product. Is it clear? So this is called scalar product. Product means multiplication. We are going to multiply two vectors, but we got answer scalar. So we are going to call it as scalar product. And here I am going to represent here A multiplied with B. Vector A multiplied with vector B. So here I am going to write a dot. Vector A dot vector B is equal to C. I am going to represent multiplication with a dot. So scalar product is also called as dot product. This is the second type of multiplication of two vectors. Scalar product or dot product. What happens here? When we multiplied two vectors, the result is a scalar quantity and is represented with a dot. So we are going to call it as dot product or scalar product. Then come to the third type of multiplication, vector multiplied with vector, but the answer is a again vector quantity. See here I am going to write example. Vector A is equal to, I am going to consider again 3i cap plus 4j cap plus 5k cap. This is the value of vector A. Vector B is equal to, I am going to take I cap minus j cap. Okay, this is value of vector A and vector B. If there is no third term, then we can take it as 0. So here I am going to multiply vector A, vector B. So after multiplication, whatever the answer we will get, so this should be vector quantity. Let us take it as C. C is our result. Right? So when vector A is multiplied with vector B, if the answer is a vector quantity, then we are going to call it as vector product, or we are also call it as cross product, because here when vector A is multiplied by vector B, I am going to write a cross here. This is the multiplication symbol for the result vector. Vector A cross vector B. So this is called vector product, or we can also call it as a cross product. When vector is multiplied by vector, if the result is a scalar, we can call it as a scalar product or a dot product. If the result is a vector, then it is called as a vector product or cross product. Suppose the answer is a scalar quantity and then multiplication is represented by a dot. If the result is a vector quantity, then multiplication is denoted by cross. Is it clear? A dot B is a scalar product. A cross B is a vector product. So this is all about the types of multiplication of two vectors. Now we can study in detail about the second type, that is scalar product, or we can also call it as dot product. In today's session, we are going to study in detail about scalar product or dot product. Yes, first we can observe the definition. The dot product of two vectors is defined as the product of magnitude of two vectors and cosine of angle between them. If you are going to consider two vectors, if two vectors are multiplied, then how to define scalar or dot product? The product of magnitude of two vectors and cosine of angle between them. Here you can observe the equation. Vector A dot vector B is equal to mod of A into mod B into cos theta, which is equal to AB cos theta. This equation you have to remember. Observe this diagram. We considered two vectors. The first vector is A and the second vector is B. The dot product of two vectors is the product of magnitude of two vectors. Here we have to consider magnitude of two vectors. Magnitude means it's only quantity, not direction. When we are talking about only magnitude, always we have to use mod P or mod Q. So that mod gives only its magnitude. Is it clear? For example, if I am going to consider mod of minus 5 and mod of plus 5, what is the answer? Here also we got 5 and here also we got 5. There is no value for this negative sign because it is having only magnitude, no direction. So whenever you are going to represent magnitude, let us consider mod. Right? Here we considered two vectors. Angle between these two vectors is what? Theta. Then how to define dot product? It is the product of magnitude of two vectors and cosine of angle between them. Now the question arises, why we have to consider the trigonometric function cosine? So remember, whenever we are going to consider trigonometric functions like sine, cosine or tangent, so that function is suitable. Is it clear? For that equation, which function is suitable, that we are going to consider. Here we already studied in the previous class, you can remember direction cosines of the vectors. Whenever we are going to talk about the direction, the suitable trigonometric function is cosine. So we are going to consider cosine of angle between them. So how to write the equation? Vector A dot vector B is equal to mod of vector A into mod of vector B into cos theta. Mod of vector A means what? Its magnitude. That is A. Don't write arrow mark here. This is completely wrong. If you are going to write arrow mark on the top of the alphabet, that gives vector quantity, means direction. But here we consider only magnitude. So here don't write any arrow mark. So here mod of vector A is equal to A, mod of vector B is equal to B, and this gives only magnitude, no direction. Mod of A into mod of B into cos theta. Theta is angle between A and B. Here the suitable function is cosine. Cosine is the direction vector. So we can write AB cos theta. Is it clear? Vector A dot vector B is equal to, how to write the equation? A into B into cos theta. If I am going to consider vector P dot vector Q, how to write the equation? P into Q into cos theta. Or you can write mod of vector P into mod of vector Q into cos theta. Again the result is what? Same. Mod of vector P is P, mod of vector Q is Q into cos theta. Right? Theta is angle between two vectors, vector A and vector B. Note here, observe this point. Dot product of two vectors gives a scalar quantity. Yes, we know that when two vectors are multiplied, if the answer is a scalar quantity, then we are going to call it as dot product or scalar product. Is it clear? So what is dot product or scalar product? It is the product of magnitude of two vectors and cosine of the angle between them. Just you can remember this equation. Is it clear? Vector A dot vector B equal to mod of vector A into mod of vector B into cos theta or AB cos theta. Now we can study the properties of dot product. So these properties are very important. First you can observe dot product is commutative. You already studied in mathematics in 9th standard. You studied the properties. Here the same thing we are going to apply for dot product, or we can also call it as a scalar product. The first property is dot product is commutative. Commutative means you can observe this equation. Vector A dot vector B is equal to vector B dot vector A. I will give you one example here. I am going to consider vector A dot vector B is equal to, what is our equation? Mod of vector A into mod of vector B into cos theta. This is the equation. Right? Now we can consider two vectors here. This is, let us imagine this is vector A and this is vector B. And the angle between them is theta. Vector A to vector B we have to consider. In this direction angle is theta. Right? Now I am going to write vector B dot vector A to prove commutative property. Whether dot product is commutative or not, we can prove it here. Vector B dot vector A is equal to, here we can write mod of vector B into mod of vector A into cos theta. Theta is what? Angle between vector B to vector A. Initially, we considered A to B. Angle between A to B is theta. Now we have to consider B to A. B to A means, remember, angle we have to consider always in anti-clockwise direction. Vector B to vector A, here we can't consider. So I am going to take angle here from vector B to vector A, anti-clockwise direction, right? So here in the place of theta, angle between vector B to vector A. What is the angle between vector B to vector A here? Total angle is how much? 360 minus of this small angle is theta. 360 minus theta is angle between vector B to vector A. Here I am going to write 360 minus theta. Don't write simply theta here. Remember, A to B, here in the second case B to A. And the angle we have to consider in the anti-clockwise direction. So we know that mathematically cos of 360 minus theta is equal to plus cos theta. So about these conditions you have studied in mathematics, you can remember cos of 360 minus theta equal to plus cos theta. So this equation becomes vector B dot vector A equal to mod of vector B into mod of vector A into cos of 360 minus theta is what? Cos theta. Now observe equation 1, equation 2, both are same here. A dot B is equal to B dot A. That proves dot product is commutative. The second property is dot product is a distributive property. Here vector A dot B plus C is equal to vector A dot B plus vector A dot vector C. So now we can prove this equation here. Dot product is a distributive. So vector A dot vector B plus C is equal to vector A dot vector B plus vector A dot vector C. So this one we have to prove here. This is three-dimensional because three vectors are given here. Vector A, vector B and vector C. Now let us consider vector A is given. I am going to consider its magnitude and direction values in three-dimensional. So we can take AX, X cap plus AY, Y cap plus AZ, Z cap, or you can take I, J, K cap, right? Similarly, vector B equal to, how to write here? BX, X cap plus BY, Y cap plus BZ, Z cap. Then third vector, vector C equal to CX, X cap plus CY, Y cap plus CZ, Z cap. So this is the representation of three vectors. Now we can consider LHS side. Vector A dot vector B plus C. Here vector A value is given. What is the value of vector A? AX, X cap plus AY, Y cap plus AZ, Z cap. This is the value of vector A dot. This is vector A dot into bracket vector B plus vector C. Here vector B plus vector C. We can add the vectors here. So I am going to write, observe here, vector B equal to Bx x cap, vector C equal to Cx x cap. We can take x coordinate. I am going to add here Bx plus Cx and its direction is what? X cap. Plus, similarly, we can write By plus Cy, Y cap plus Bz plus Cz, Z cap. Right? Now, we can write, now we can multiply these values Ax into Bx plus Cx. What is the value of x dot x or I dot I? X dot x value is 1. Y dot y value is 1. Z dot z value is 1. So how the value becomes 1, that I will explain in the next property. Observe here Ax Bx plus C plus, similarly we can write Ay into By plus Cy plus Az into Bz plus Cz. So this is the LHS value. Similarly RHS is given Observe the equation. Vector A dot vector B equal to vector A dot vector C. Multiply these values here. Vector A is given AX x cap plus AY y cap plus AZ z cap. Vector A dot vector B BX x cap plus BY y cap plus BZ z cap. Vector A dot vector B. So this is plus here. Vector A dot vector B plus vector A dot vector C. Similarly, vector A value I am going to write here. AZ z cap dot vector C is what? CX x cap plus CY y cap plus CZ z cap. Now let us multiply these value. AX into BX plus AY into BY plus AZ into BZ plus for the next term let us multiply AX into CX plus AY into CY plus AZ into CZ, or we can take x terms on one side, AX BX, here AX CX, AX is common, AX into bracket BX plus CX. Then AY BY, AY CY. Here AY is common, BY plus CY. Plus similarly AZ BZ, AZ CZ, AZ is common, BZ plus CZ. Now observe LHS side and RHS side. Both are same. Observe the equation 1 and 2, both are same here. That proves dot product is a distributive property. Vector A dot vector B plus C is equal to vector A dot B plus vector A dot C. So this is the second property. First one is dot product is commutative. Second one is dot product is distributive. Then in the next session we can study the remaining properties.